Okay, good morning, good afternoon, everyone. Uh, Welcome to the ETbox webinar. My name is Koen Commissaris, and I'm part of the business development team at Tecnatom. I will be hosting today's webinar, which is about the ETboxMB eddy current inspection instrument. With me here today are Jerónimo Hernandez and Alfonso Lain. And both of them, they have played an important role in the development of the ETboxMB product. Alfonso is an NDT expert, and he has been project manager of many eddy current instrument projects, and he will be providing the demonstration of the ETboxMB instrument. Jerónimo is an expert in eddy current technology, and he has led the design and development of the ETboxMB instrument. Um, as Alfonso will be explaining in his demonstration, the ETboxMB is a portable instrument, and it has four applications. First of which is conductivity and thickness measurement. The other one is the eddy current inspection. There's rotating inspection, and also the system has phased array capabilities. To limit the length of today's presentation, we have decided not to go into much details on those last two applications. For those who, after seeing the demonstration, would like to know more about those specific features, please let us know, and we can organize a specific meeting, or maybe we will organize a second webinar session. So to explain a little bit about today's agenda, after this introduction, we will go to the demonstration of the ETboxMB. And for practical reasons, we will show you a pre-recorded demonstration, just for practical reasons, because it will be easier to show the equipment, Alfonso's hands as he is doing some of the manipulations, and also the system screen. So because it's shown from various camera angles, it's difficult to manage in a live session. So we're showing you a pre-recorded video. The demonstration will take about 25 minutes, and after the demonstration, Jerónimo and I will be answering a selection of your questions. You can submit questions through the chat of the online event, and we'll be answering those questions after the demonstration. Okay, we have a large number of participants today, and we're enthusiastic to get started. So without much further ado, I will start the demonstration and give the microphone to Alfonso.
Welcome to the ETboxMB webinar. I'm Alfonso Lain, and I'm going to introduce you to a comprehensive inspection system based on eddy currents for manual inspections. This is an advanced, ultra-portable system with array capacity. It's designed to operate in industrial manufacturing settings or inspection and maintenance tasks. This equipment and its attributes are meant to meet the needs of industries as demanding as aerospace or energy. The system features a comprehensive software tool that's totally adjustable and has user-friendly tactile interfaces, as well as a wide range of pencil, array, or rotating sensors that are particularly designed for conventional and advanced eddy current applications. It's also supplied with the calibration blocks that are necessary to carry out the most common inspections. This way, by purchasing any of the ETboxMB packages, you will have all you need to start working right away. Let me show you the content of the case. Here we can see the main elements the inspection system is made of. This would be the eddy current instrument, and this is the tablet where the software used for the acquisition and display of data, as well as any necessary settings and operations, is installed. Most of the portable equipment in the market consists of a set with the screen and the electronics all in the same casing. The ETboxMB equipment changes this concept and separates acquisition electronics from the user screen for two main reasons. First, nowadays, we're all very used to managing cell phones or tablets, devices with very vivid color screens and high resolutions. However, most compact equipment in the market has monochrome screens with low resolution. The ETboxMB allows for a next-generation tablet, PC, or any other device that's compatible with Windows that allows for easy updates that follow market trends. The second reason is ergonomics. In compact equipment, the probe is usually connected through a cable. Therefore, if we move along a large component, our range will show the cable length. If we move further, we'll have to keep shifting the whole equipment. However, with the ETboxMB, we can rest the screen somewhere, and we can move freely since the equipment will be attached to our waist, and the probe cable set will move along with us. As we can see, the ETboxMB is small enough to be transported easily to any inspection area, and powerful enough to act as a desktop on laboratories. It weighs around 700 grams, has a robust box that's resistant to falls and watertight, which means it's sealed against liquid splashes and can be operated in the rain, for instance. This is a multi-channel equipment that allows us to acquire up to 4 frequencies for the detection of indications, and whose range goes from 10 Hz to 10 MHz. Let's talk a bit about its front panel. Here we have a number of LED status indicators and a number of connectors. First and foremost is the probe connector, which allows for different types of probes, both from Tecnatom and from third-party manufacturers. Then we have the digital inputs and outputs connector. With this one, we can interact with other elements, take out alarms, work with encoders, etc. There's also a USB port we can use to connect it to the tablet through a cable, although communication is usually done via Wi-Fi. And finally, we have the power supply connection that allows us to work connected to a power supply even while the battery is charging. Let's talk about the battery. The equipment has a range of up to 8 hours during the use of a conventional probe. This allows for great flexibility since a whole inspection journey can generally be completed. On the other hand, the equipment usually comes with a rugged tablet, although any device that comes with Windows 10 will be compatible with the system. The fact that the user interface runs on a tablet allows, on the one hand, for user-friendly interaction via the touchscreen, and on the other hand, for the use of tools, such as picture taking with the photo cameras included in the tablet, report generation, or even cloud file management if we connect the tablet to the internet. This new equipment deserved the development of new probes. That is why, for this system, different probes with new features have been developed. Like, for example, configurable buttons, lighting LED, or even automatic detection thanks to the inspection system. Therefore, the ETboxMB equipment developed by Tecnatom and its whole ecosystem is perfect for eddy current tests, as it allows for the fulfillment of all requested tasks in a reliable, easy way, and with a single instrument. In applications for industries such as aeronautics, the need to measure conductivity changes is very common. For example, changes produced by overheating on the brakes over the wheels. Similarly, the thickness of paint layers or coatings with materials that are non-conductive of metallic components are also measured. The ETboxMB equipment allows to do such measurements independently or as a whole, in different working modes. As we're going to see, this tool guides the operator with the easiest graphic interface. Let's see an example using this probe, especially developed to measure conductivities. As we can see, the probe has a small LED that lights up with the alarm that we can set up, and it's a probe that works at 60 kilohertz. For this demonstration, we also have two conductivity measuring blocks. In this case, these are two aluminum blocks that have their own certificate. These blocks are manufactured and certified by Tecnatom to calibrate the conductivity test. On the other hand, for the thickness test, we have several certified patterns with different thicknesses. In this case, we've got gauges that go from 53.7 to 512.8 microns, depending on the range we want to work with, as we will need different gauges to work with different thicknesses. Moving on, let's start our conductivity thickness application. It has identified directly the probe we have connected. Okay, this is the main screen that, as you can see, is a bit different to the ones we've seen before, because on this screen, we set up the calibration we're going to do. On this menu, we can choose between work modes. If we want to measure just the conductivity, just the thickness, or do a mixed measurement of both of them. We can also choose the units in which we want our measurements to appear. We can go between megasiemens per meter or IACs, or between microns and inches. In this case, we're going to work with the international system. We can also choose the units in which our temperature will appear, either Celsius degrees or Fahrenheit degrees. It's important to introduce the test temperature since, under that, the algorithms are going to work with it to obtain better accuracy. Okay, so once we introduce the conductivity and thickness values of the patterns we're going to use to calibrate, in this case, I had already pre-charged them, but their tactile insertion is very easy. One is 26.96 and the other 46.38. And for the thickness measurement, we're going to do it between a zero gauge, that is, with no gauge, and use a medium thickness of 129.1 micron. Once we have everything ready, we click on Next, and the software is going to guide us directly through the steps we need to follow. In this case, we put the probe on the air. To get a reference, it tells us with the lowest conductivity and lowest thickness pattern. We hit Next, lower conductivity and higher thickness, Next, and higher conductivity and higher thickness, and higher conductivity and higher thickness. Okay, so this is how easily we've done a calibration for our conductivity and thickness test. Now we can see on the screen some menus and submenus that look more familiar to us. In the upper middle section of the screen, we can see the conductivity measure, and in the lower part, the thickness measure. On the Technical tab, we find a description of a series of parameters we can choose. That would be the acquisition mode, which is in this case automatic, and the software identifies if the probe is on the air or if it's laid on the material. When the measurement is fixed, it goes blue. If we set it to continuous, this is measured non-stop. It refreshes our measurements constantly. If we change thickness, we can see both are visible all the time. Finally, if we have set it to manual, in this case, we have to do a screenshot of the measurement ourselves. Every time we hit screenshot, it takes a screenshot. One of the options that's activated right now, which we can turn on or off, is one to calculate the average of measurements. we have up to 8 fields. This application is really useful when we have to inspect a large component and we take a sample in which, according to our procedure, we have to measure several times. That way, we capture the measurements, then another, and it calculates the average directly in order to understand what the conductivity or the thickness of that component is. On the other side, we also have an alarm set up. In this case, they've already activated, and we can see that the alarms go off when they're out of range. We also have the opportunity to change the display, but here we can only change between conductivity, thickness, or see both measurements. We have the chance to generate reports as well, but we'll see that later. This would be a general example of how to perform a combined inspection of conductivity and thickness. It should be noted that all of the algorithms used that back up the calculations of these tests have been subjected to thorough accuracy tests in order to ensure they are compliant with the most common demanding guidelines. To detect and set apart open cracks that are superficial or subsuperficial in inspections of components manufactured with conductive materials such as landing wheels, fuselage, or pipes, it's necessary to do the test via eddy currents to different frequencies. In order to do that, the ETboxMB equipment can be set up really quickly and work with up to 4 frequencies simultaneously. We can even modify the test parameters to meet the inspector's needs. I'm going to do a demo where, with a basic setup, we'll do a calibration and acquisition of this calibration block with 3 notches. To do so, we're going to use this pencil probe. It's a probe developed by Tecnatom, whose work range goes from 500 to 1000 kilohertz. It has a push button, so in this case, we've set it up so that we can use a long push to turn on the LEDs and the short push to do a hardware null. It also has a small LED that lights up when we have configured our alarms. We're going to start the eddy current application. It identifies our probe right away. Okay, so in this case, we've already seen the distribution of the screen. Let's configure the display the way we want it to perform our inspection. For that, we'll go to the display menu where a sub-menu spreads out. We have a Lisa Juice open, and we're going to use strip chart with Alicia Juice. Once we have that part configured, we can also see there are several other options among which we can choose. The equipment is acquiring, and it's important to take into account that we can turn the persistence mode on or we can turn the persistence mode off. That way, we see that if it's turned off, the whole signal that's acquiring until the buffer is full accumulates on the screen. However, if we turn it on, what we see is that it only represents the 2 seconds that we have configured. We're going to leave it that way to work. We go back to the technical menu and we start calibrating. The first step is to focus our signal in the impedance plane. To do so, we will do a hardware null. And as we can see, it's running now. Our signal is focused both in the horizontal and in the vertical components. To perform our calibration, we acquire the liftoff and the 3 notches. We make several passes. Okay, now we stop our acquisition. As you can see, we've got a timeline where we can see the signal that is accumulated in the buffer. That is, from the latest 20 seconds. And with this window, we can choose whether we want to see more or less data on the strip charts. We're going to close the window and choose Well, we're seeing this stage. The first thing we have to do is to change the phase. We can also see the phase in this menu, which is 0 degrees in this case. And we can rotate the signal via the touchscreen in order to assign the phase we need to it. As we're seeing, we put the liftoff signal horizontally, which is a common way to calibrate the phase. Now we calibrate gain. In order to do that, we have to search the area where we have acquired the notches. Right now, we have a very low gain. On this screen, we can see we can manipulate the gain so that we can change both components at the same time. We can put it directly on screen or even through the touchscreen. In this case, let's give both components a bit more amplitude so they have enough entity. All right, once our equipment is configured and calibrated, we can see some other features of this application. Both of them are related to display. We can also see we have 2 tags with the measurements. In this case, phase volts and peak to peak. These 2 measurements that appear on the sides of the tag with the channel we're working on are configurable. I mean, we can choose volts, peak to peak, phase, volts on the horizontal, or on the vertical. Okay, the whole screen can be configured. Once we've seen that, we can talk about the tag. That's on the alarm section. We have up to 4 alarms ready to be set up. In this case, they're deactivated, but we're going to activate them. Okay, we have several alarm modes. I have activated one that's the polar one, but you can also use the one that's thresholds, for example, horizontal, rectangular, circular, or polar thresholds. All of them are configurable via the touchscreen. We can enlarge them, reduce them, depending on the area of the impedance plane that we're interested in working with. For this example, I have chosen a polar pattern, and we're kind of sure that the signal amplitude of our biggest entity notch is going to reach this point. Okay, well, we're all set. Let's acquire the notches. We see that the first 2 do not have enough entity, and the last one, as it already breaks the alarm that we have prepared, the LED lights up and we have the luminous signal. Every time we pass through it, we would be triggering the alarm. And this would be an example of how to work with alarms. Likewise, if we need to work with several frequencies, well, it would be as simple as configuring and activating one more channel. So we can see that the screen is divided, and we have available the same frequencies that we had for a single channel for both. If there were 3 or 4, it would be exactly the same. Thus, as this is the basic eddy current application, it is still enough for a bunch of inspection applications. In addition, it has the possibility of using a wide range of different types of probes to adapt to the most complex geometries with very low costs. To conclude, let's see some tools that are common to the 4 ETboxMB software applications. These are, as we see on the screen, the ones we find in the Utilities and Reports tabs. If we select the Utilities tab, we see that we have the possibility to save data, save configuration, load configuration, and view our system information. This is the screen we see when we run it. We can also look here to see the probe that's connected, the software version, and the setup of the current instrument. If, for instance, we're performing an inspection and we need to save the signal we have acquired, it would be as simple as hitting Save Data. Create a folder and and call it web. Then create a file name that we will call file. That way we would already see all the saved data we have on the screen. Then, if we have to recover them, we would just have to click on Load Data. We can also save the configuration. Similarly, it asks us to type the name of the configuration we want to save. And this way, if another operator or some other time we return there and we want to load the same configuration or review the data, we would already have them available. A very relevant and very useful application when carrying out inspections is the report generation. For this, we have two tools. One of them is the screen capture tool. If we've acquired an indication that we consider important, for some reason we want to save what we are seeing, and if we want to save what we're seeing, press Save, and it saves the image we're looking at. And if, for example, we are looking at an indication and we want to take an actual picture of said area, it's as simple as opening the camera application. In this case, I'm going to take a picture of what I have to calibrate. We take it, and it's available. That way, if we go to Reports, we have both the screenshots and the image we have acquired. Besides, by clicking on Add Configuration, an image would be saved with all the configuration data we have used to perform that inspection. And in this way, if we were to click on Generate Report, it generates a Word file that we can see. It generates a Word file that has been created in the folder. This Word document grabs a template, and as we can see, let's enlarge it. Well, in this case, we could fill in all the client's data. It's an example. And it has already inserted right away the images of the acquired screen, as well as the photo or the configuration of the equipment. We go back to the application. Okay, as we have saved it before, we will see we have the file we saved, and that we can visualize, reevaluate, and study it. As you can see, these applications complete a software tool really designed to make field inspection tasks as easy as possible. It gives us the chance to have a fluid workflow from the purest technical operations to all of those documentation and processes that require non-destructive testing procedures. And that's a wrap for the ETboxMB webinar. Throughout this series of explanations and demonstrations, I've tried to show you all the capabilities this powerful inspection equipment can offer. For more details, and if you want to learn more about this and other non-destructive testing equipment, you can check out our website and contact us. Thank you very much, and see you in the next video.
Thank you, Alfonso, for that demonstration. I hope you all enjoyed the demonstration of the equipment. We've received several questions through the live event Q&A, so we will be going through those. With me here, as I said before, is Geronimo, that will be answering the questions. So Geronimo, if you can say hi to everyone.
Yes. Hi, everyone. You have the question?
Yeah, so first question is, will the tablet be supplied with the equipment?
Okay, there we have different options. We can supply the tablet, could be different sizes, could be a 7-inch, could be a 10-inch, could be a 12-inch tablet, could be a standard tablet, it could be a military one. We have several options that I can show you. This is a military version of a 7-inch tablet. This is a military 10-inch tablet. That could be also a standard, could be supplied by us, or you can buy by yourself. You can use your laptop. There are some customers that use his PC or laptop because they do some laboratory tests, so they just use his laptop and they don't want any tablet. So it's up to you. We will give you the software and you can use your PC, or we will provide you the tablet or any other Windows 10 computer will be okay.
Okay, thank you, Geronimo. Let's see, next question that was asked is it possible to generate a report in a custom format? So is it possible to generate reports according to a custom report format?
Yes, regarding the report, Alfonso tell us something on the demonstration. It's all the information that we just acquired during the acquisition, all these screenshots and photos and all those things will go directly to a Word document, and it's a template, so you can create your own format, your own document. The only thing is that you will have inside the document, you have to have a label that is called images in some part of the document. Where this label is, it will just insert all the different information we have recorded during the inspection. So you can create, it has to have a special name, this document, and it has to be in a folder on the system, but we will give you all this information so you can create your own format.
Okay. Next question, what is the maximum inspection temperature of the material to be inspected with the pencil probes?
Okay, with the standard pencil probes, it depends on the material we use to cover to protect the coil. But normal working temperature is 60 degrees Celsius. But for some customer, we have do some modification of this protection layer. We were able to inspect up to 200 degrees Celsius. Okay, the customer used to inspect the tubes well as in thermosolar power plants.
Okay. Let me see, next question. Does Tecnatom manufacture probes according to customer specifications? So do we manufacture custom probes?
Yes, I think it's part of our nature because we create probes from many years. Some of them are became standard because we use regularly, but most of them are custom even for us. So we have the capability to do custom probe could be pencil probes, or could be arrays. Okay, we have some. I will show you. We have some arrays that we made, so that could be this. In this case, is a 8x2 semi-flex probe. This is an array for subsurface defect inspection, but we have also full flex array probes. This is a cross coil array probe for well inspection. So we have different capabilities to do custom probes or any kind. Okay.
Okay. Next question. How frequently does the equipment need to be sent in for calibration? So how frequently does the equipment needs to be calibrated?
Okay, so it depends, because we have our internal laboratory for calibration and testing of the instrument, and it depends on your procedures and what is the application of the instrument you are going to use. Usually in Europe, we just calibrate the instrument for 1 year. So every year you have to recalibrate, but it will depend on your needs or your procedure.
Okay. Next question is, do EASA and FAA approve this equipment? So are these equipments EASA and FAA approved?
I think we have the CE marking, and I think that they have also a NATO approval, but I don't think that we have for FAA or ESA.
Okay. Last question. What new functionality is Tecnatom looking to add to this equipment in the future? So what other features do we foresee in the near future for this equipment?
Okay, that's and the software, it's always running and updating. We are always working on new things, adding to the software to increase the capabilities and power of the system. And now we are working on adding a map of conductivity. So in case you are going to inspect big areas of the plane or wherever is the structure you're going to inspect, so it will give you a map of conductivity of the whole area. And also we are preparing also for the array, the possibility to inspect also big areas of array, or what we call a multi-line process. So it will give you the possibility to scan different lines or dividing lines your area, and create at the end a full C scan. So we are working always on the software, and new things are coming. Sure.
Okay, thank you very much, Gero. I'm afraid that is all that we have time for today. So there are some other questions that will be responding through email. I hope everybody has enjoyed the presentation, the demonstration, and we'll be looking to hearing from you soon. So Geronimo and Alfonso, thank you very much, and we'll leave it at that for today. So thank you, and goodbye, and see you soon. Okay, bye-bye.